Hello YouTube, and welcome to another video. In this video I'm going to be looking at one of my original Pylontech batteries. Now these aren't the current ones that are available for sale now. These were the very first generation that Pylontech did. They were called Extra 2000s. Now I bought this battery, was my very first, my original battery, and I got it with my very first solar installation over 8 years ago. It's supposed to have a lifespan of 4,000 cycles, which would be about 10 years. So I've had it 8 years, and it's if you've seen my previous video, you see I mentioned that it's got a problem. It's not performing as it should do. But I wanted to do a proper investigation and see just how much capacity it's lost after those 8 years. But bear in mind that when I had my solar system fitted, these batteries were really expensive, and I only could afford one at the time, which is this one, the very first one. And so it had a very rough life in the early days, because it was basically supplying all the loads and stuff from the inverter when I was running through the night, and that's a lot to ask of just one battery. So it was quite often exceeding what was its recommended current output, and it was quite often being charged at higher than its recommended current input. So it had a rough life, so I never expected it to last the full 10 years, and so I think 8 years is probably pretty good for the kind of life it's had. So yeah, let's have a look at it and see what's going on with that battery. So I got these from Halfords. These are just standard car headlight bulbs, and obviously, because they're from a car, they're 12 volts, and they are, well, they've got two elements in them, but I'll just use the dipped beam element, so it's 55 watts. So if I put all four of these in series, that will make a 48 volt circuit, and 55 watts times 4 is 220 watts. So 220 watts, each of these batteries is supposed to be 2.4 kilowatt hours. So it's probably about 2.2 or maybe only 2 kilowatt usable. So if these are 220 watts, it means it should be about 10 hours of them running continuously should drain the battery, which yeah, I can record. So what I'm going to do is get these opened up and chain 4 of them together in series, and make a circuit, and then we can take it from there. Now I've got this is the type of connector that these original Pylontech batteries take, and yeah, this was one of the old wires. So what I've done is I've cut it and stripped off the ends, so that bit can plug in the battery, and then I can run my circuit through these 4 bulbs and back. And I'm going to do that using just these crocodile clips for now. Now I've worked out that there should be about 4 amps flowing through the cable. Now 2 of these together might not be enough for 4 amps. It's quite thin cable.
so it could get quite hot. But I've got some more, so I could probably get about 3 on here if I need to, and we'll see how that goes. And if I'll do a quick test, and if they get too hot, then I'll have to go and get some thicker cable, and I'll have to wire up something a bit more substantial, let's say, than this cable, because these have effectively got to be 2 amps down that piece of cable, and I think that's probably, well, we'll see. We'll see. Now, I'll test it like this first, just to see if this is going to work, and then what I'll do is I'll tape up these ends so that there's no chance of these touching each other, because otherwise that would dead short the battery, which would not be a good thing, although the BMS would just shut it off, but it's still not going to be a good thing. So I'll put electrical tape all around that, if these cables are going to be thick enough. Otherwise, yeah, I'll have to wire up something a bit more substantial. Okay, so there's the circuit. So the current should travel from the battery through this bulb, through this bulb, through this bulb, through this bulb, and back to the battery. And so it's a 48 volt battery, and so with these being in series, there should be 12 volts across each of these bulbs, which is what they're rated for. And so it should burn about 55 watts in each bulb, so that's 220 watts. So I estimate if the battery was brand new, it'd be roughly about 10 hours it should drain the battery. But we'll see what it actually does, because I think it's lost quite a bit of capacity in the 8 years since I've had it. So get it charged up and get it out of its current place in the cupboard and put it somewhere where I can film it, and then we'll get this connected up, and we'll record the results and see how long it takes to drain. Okay, the battery is fully charged according to my inverter, so just check the voltage before we start. $52.7. So let's plug. I've added an extra wire just to spread it out a bit. We'll see if this is enough. I might have to start again if these wires start to get too hot. And let's start the stopwatch and go. Oh, it's bright. I'm pulling 5.2 amps. My thermal camera to have a look and see what we've got. So the bulbs themselves are obviously quite hot, but the wires, they're not showing up hardly at all. I mean, the ambient temperature in here is probably about 30 degrees anyway, because it's really hot today.
we'll keep an eye on that. Yeah, the wires look fine. Been an hour now, so let's just have a look at what we're going. I've got this fan set up here blowing over the bulbs just to carry some of this heat away, because they really are quite hot. So 280 degrees it says those bulbs are. But again, the wiring is fine. It's not even standing out from the background. These mats that it is on is probably getting quite toasty, but that's why I put the fan there. So far so good. 1 hour in. Keep going. I just came back to check for hour number 2, and it seems like they've gone out at some point. So I'll have to check the footage on the camera to find out when exactly that happened. But that's not very good. That's like 2 hours at 220 watts. That's not even half a kilowatt hour. So this battery is very, very seriously degraded, it seems. But let me look into it some more and come back with some actual figures of what we've got. It's taken a few days to recharge the battery. We've not had a lot of sun lately, but it's fully recharged now. So what I'm going to do is I'm going to open it up, because it's quite old, so it's not under warranty or anything anymore, and clearly it's not working very well. So I'm going to open it up and I'm going to test each of the individual cells to see what their voltage is. Now, my suspicion is that one of them is going to be lower than all the others. So we've probably got either an unbalanced pack, or potentially, if they're all at the same voltage, then what we've got is one of them that is weaker than all the others now, after 8 years. And as the battery pack discharges, that one will discharge much faster than the others and will hit its lowest voltage before the others do, and the BMS will then cut off the whole pack, even though there's quite a lot of voltage left in all the others. So in my ideal scenario, it will be the first situation where one of them's just not fully charged and the pack's just got out of balance, in which case I'll be able to manually charge that one cell up to the same level as the others, and then hopefully that will give more capacity for the pack as a whole, because then they'll all discharge at the same rate and they should all be able to get down to their lowest value before the BMS cuts it off, and that should give us a lot more power output from the pack. But otherwise, if there's one of them that's weak, there's not an awful lot I can do about it. The only real solution would be to find an old one of these on eBay somewhere that no longer works, one that's approximately the same age, and maybe be able to try taking one of the pouch cells out of that and replace the bad cell in this one to make it work. But whether it'll be worth doing that, I'm not sure. But first, let's get the top off and have a look inside and see what state it's in, and then we'll decide what to do from there. So this is a bad sign. You can see this pouch here is very swollen. which means that this pack is almost certainly dyed. The rest of the pouches seem fine, but this one is definitely going to be the problem one. So I think this pack is pretty much going to be no good anymore unless I can get a replacement for this pouch cell. And let's say whether it's worth doing that, I don't know. Maybe I'll have a look on eBay and see if anyone's selling one of these old units, but we'll have a look. Well, I'll get this pouch out anyway, and then we can test its voltage. Let's see how much this one sticks up compared to these ones. There you go, you can see how bulging that is. I move around. Big bulge in there, and to a lesser extent on the bottom. But yeah, basically this is the bad pouch, or actually inside here there'll be many pouches, and probably just one or two of them have actually expanded. The rest are probably okay, but I think I will leave it there for this video, and I'll dismantle this in another video to find the actual problem pouches. But really my options are to get a new one of these from an old pack, or potentially to take these out and replace them with brand new ones, and then obviously keep the BMS and the housing and everything, and just put brand new pouches in. This will be a 16p configuration, so there'll be effectively, this will be a 4p in each of these packs. So as long as I can get lithium iron phosphate cells, and I can effectively get 16 of them into here, then this BMS would work fine with that. It's whether or not I can do that, and whether or not financially it makes any sense to do that. It might be better off to just buy a brand new one of the Pylontech, the more modern ones, and be done with it. Sell this off as spares or repairs on eBay or something. But before I do that, though,
I will dismantle this in another video so we can find the bad pouches and see how bad they are. Okay, I'll leave it there. Thanks for watching.